Welcome to the DIY Honda Garage channel. The DTC P0339 is a diagnostic trouble code indicating an intermittent interruption in the crankshaft position CKP sensor circuit. This sensor plays a crucial role in engine operation as it provides vital information about the position and speed of the crankshaft to the engine control module, ECM, or powertrain control module, PCM. The CKP sensor is typically located near the crankshaft or in the engine block, detecting the rotation of the crankshaft with a pulse plate that generates electrical signals. When the CKP sensor malfunctions, it can lead to performance issues, including misfiring or stalling. Proper troubleshooting is essential to ensure that the vehicle operates effectively. The first step is always to document any freeze data and perform a thorough review of the onboard diagnostics. The crankshaft position, CKP sensor, is pivotal for modern vehicle engine management systems, as it relays critical data regarding the crankshaft's rotation to the powertrain control module, TCM. This information allows the PCM to optimize fuel injection and ignition timing for smooth engine performance. In the Honda Odyssey, the CKP sensor is usually situated near the crankshaft, often within the engine block, ensuring it has direct access to the crankshaft's movement. With this positioning, the sensor can detect the speed and position accurately. An intermittent failure in this circuit can lead to serious reliability issues, affecting your vehicle's performance and drivability. Components like the pulse plate interact closely with the CKP sensor and must also be inspected during troubleshooting. If any issues are detected in this component circuit, it can result in the DTC P0339 being triggered. A few specific issues could lead to triggering the DTC P0339 in your Honda Odyssey. Firstly, poor electrical connections are a common culprit. If the wiring to the CKP sensor or PCM is corroded or improperly connected, it can interrupt the circuit. Loose terminals can also cause intermittent failures, preventing reliable communication between the CKP sensor and the PCM. Additionally, damage to internal components, like the pulse plate, can result in poor signal generation, contributing to the circuit interruption. Ensuring all connections are solid and inspecting the sensor and its associated parts are critical first steps in the troubleshooting process. Identifying whether these issues exist can help narrow down the source of the malfunction. Each potential cause requires careful examination to ensure that the system operates correctly. When experiencing DTC P0339, several symptoms may present themselves in your Honda Odyssey. A common sign is engine misfiring, which happens when the timing of spark generation is disrupted, causing a rough engine operation. Drivers may also encounter stalling, particularly during acceleration or while idling, as the engine control module, ECM, struggles to maintain optimal performance without accurate crankshaft position data. Inconsistent engine performance may manifest as unexpected power loss or irregular vehicle behavior, making driving unpredictable. Understanding these symptoms is crucial, as they not only affect your driving experience, but can also indicate potential long-term damage if not addressed promptly. Thoroughly diagnosing these symptoms can provide insight into whether they are directly related to DTC P0339 or other underlying issues. Paying attention to these problems can lead to effective distribution of troubleshooting efforts. The first step in troubleshooting DTC P0339 involves turning the ignition switch to the on position without starting the engine. This action allows the Honda Diagnostic System, HDS, to access the vehicle's electronic controls. Following this, you will need to clear any existing diagnostic trouble codes using the HDS which resets any error signals currently in the system. After clearing, start the engine and let it idle for approximately 10 seconds to allow the system to stabilize and gather new data. This initial step is essential as it prepares the system for a thorough evaluation, making the next diagnostic process more accurate. Observing the vehicle during this initial idle period is also important, as it sets the groundwork for understanding how the engine behaves under normal conditions. This basis allows a clear comparison when you check for potential issues later in the process. In this step, monitor the onboard diagnostics OBD status using the HDS to determine if DTC P0339 persists. The HDS will provide diagnostic indicators indicating whether the system is operating normally or if a failure has occurred. If the HDS shows failed, it suggests an ongoing issue with the CKP sensor circuit that requires further investigation. Conversely, if the HDS indicates passed, this may suggest that the problem is intermittent or that it has resolved itself, potentially due to a momentary connection issue. If the result is not completed, allow the engine to continue idling until the test procedure completes for more accurate data. Documenting each of these indicator states is critical, as they inform your subsequent troubleshooting steps and give insight into the CKP sensor condition in real time. This precise monitoring can often direct you quickly to corrective actions. Complete a test drive of the vehicle for several minutes, focusing on the specific parameters indicated in the freeze data recorded earlier. This includes monitoring engine speed and vehicle speed, as these factors are vital for a thorough evaluation of the CKP sensor functionality in various operating conditions. After the test drive, use the HDS to check the OBD status for DTC P0339 once again. An indication of failed means that the issue persists and requires more intensive investigation. If the HDS indicates passed, it suggests that the system is functioning effectively at this time, but still warrants checking for potential loose connections or poor terminal conditions that could lead to intermittent issues. Documenting results from this step allows you to discern whether the problem is consistent or potentially spurious, providing valuable information for future troubleshooting steps. At this point, carefully inspect the CKP sensor and powertrain control module, PCM, for any signs of poor connections, corrosion, or loose terminals. These components are vital as they play critical roles in the electrical circuit linked to the CKP sensor. Ensure that both the engine ground and body ground are also secure and free from damage. A damaged ground can lead to erratic sensor behavior and unstable readings, which would trigger DTC P0339. If all connectors and terminals seem to be in good condition, it leads to the conclusion that the issue might not lie with the electrical connections. Conversely, if you detect any issues, such as frayed wires or oxidation, repairing these connections or replacing damaged components is essential before proceeding to the next troubleshooting step. Understanding the function of every component involved is vital in diagnosing and mitigating failures correctly. If you have ruled out electrical connection issues, the next step is to remove the oil pan to access the CKP sensor pulse plate. The pulse plate is a critical component that the CKP sensor interacts with. It needs to be in good condition to provide accurate feedback to the PCM. Inspect the pulse plate thoroughly for any signs of physical damage, such as cracks, dents, or wear that might affect its ability to generate correct signals. A compromised pulse plate can lead to incorrect readings, causing DTC P0339 to activate. Documenting the condition of the pulse plate will ascertain if it requires replacement. If damage is evident, promptly replace the pulse plate to restore proper functioning of the CKP sensor system. This step is essential as it often addresses the core issue linked directly to the DTC. If the pulse plate is in good condition, the next logical step is to turn the ignition switch to the lock 0 position to safely replace the CKP sensor itself. The CKP sensor is responsible for providing the PCM with vital data about the crankshaft's position and speed, and a malfunctioning sensor can directly trigger DTC P0339. Installing a new sensor involves careful handling to prevent any damage during the replacement process. Once the new sensor is fitted correctly, turning the ignition switch back to on will allow you to begin the resetting process for the PCM using the HDS. This reset is critical as it helps the PCM learn and adapt to the new sensor, allowing for improved operational functioning. Following this step sets the foundation for successful troubleshooting and vehicle repair. Next, turn the ignition switch to the on position once more. Utilize the Honda Diagnostic System, HDS, to reset the Powertrain Control Module, PCM, an essential action after replacing the CKP sensor. The PCM may need to relearn the idle settings and other operational parameters for optimal performance with the new sensor. Following the reset, perform the PCM idle learn procedure, which allows it to gather new data regarding the engine's idle characteristics. This process ensures the sensor is integrated correctly into the engine management system, ultimately contributing to better operation. Skipping this step could result in ongoing performance issues or incorrect readings. Proper attention to this procedure is fundamental for ensuring the vehicle operates efficiently and effectively after repair. In this final verification step, ensure that you successfully clear the DTC using the HDS after performing all necessary repairs. It's vital to validate that the repair actions address the underlying issue, so undertaking a road test is crucial. This test allows you to assess vehicle performance under normal driving conditions, confirming that the CKP sensor is functioning as intended. During the road test, monitor for any reoccurrence of DTC P0339 or related symptoms. If the vehicle runs smoothly and the DTC does not reappear, this indicates that repairs were effective. It's imperative to document the results, providing clear evidence that the vehicle has returned to optimal operational status. This careful validation affirms that the troubleshooting steps taken were successful, ensuring long-term reliability for the owner. To prevent the reoccurrence of DTC P0339 and ensure the long-term reliability of your Honda Odyssey, regular preventive maintenance is recommended. Begin by scheduling routine inspections of the CKP sensor and associated wiring, ensuring that any possible signs of wear, corrosion, or damage are identified early. Maintaining clean, tight electrical connections is crucial. Regular cleaning can help prevent connectivity issues that could trigger intermittent failures. Furthermore, periodic diagnostics using the HDS can assist in early detection of any potential issues, allowing for timely interventions. Proper fluid maintenance and ensuring engine grounds are secure can also contribute to overall vehicle health. Implementing these proactive measures allows vehicle owners to avert future failures connected to the CKP sensor circuit. In conclusion, diagnosing DTC P0339 requires a comprehensive understanding of the CKP sensor's role in engine management. Understanding its importance in providing critical feedback to the PCM helps in grasping how its failure can affect overall vehicle performance. Identifying symptoms such as engine misfires and stalling is key to recognizing when to act. Careful consideration of possible causes, such as poor connections and damaged components, guides effective troubleshooting. Implementing thorough testing steps, from clearing the DTC to conducting a rigorous verification process, ensures that repairs are successful. Regular preventive maintenance further strengthens the reliability of your Honda Odyssey, helping to avoid future issues related to the CKP sensor circuit. This structured approach not only enhances immediate engine performance, but extends the longevity of your vehicle as a whole. Please like and subscribe to the channel. See you next time.